previous video, we talked about the different ways of inferential statistics, and we said that one was hypothesis testing and then the other one was estimation. We talk about hypothesis testing steps, and then we tell you that how it's not much popular, and you can have more readings in MATLAB book in chapter 10, because it is the very highly used statistical analysis. You should have a sound understanding of it. Now, when we do the hypothesis testing, we talk about z-test, one sample t-test, two independent samples t-test, paired t-test, ANOVA. It can go for a lot more tests that they are all parametric tests. For all of those, what you need to do, restate the research question as a null hypothesis and alternative hypothesis. You set a significance level, which we call it alpha, and if it's not mentioned, it's normally is 5% significance level. Significance level is the probability of wrongly rejecting the null hypothesis, or rejecting the null hypothesis when it is true, and that is what the statistician set it himself or herself. And it is the probability of type 1 error, because as you know, when we do all these testings, we are not sure if we are making a mistake or not. We just do the steps of hypothesis testing and come up with a p-value, and according to that p-value we accept, or actually we say we haven't got enough evidence to reject the null, or we have enough evidence to reject the null hypothesis. So what we do, we take a random sample from the population of interest, and then we do according to what test we are using. Is it a z-test, t-test, ANOVA, or whatever, and that the test depends on what is our research questions, how many samples do we have. Are we testing for averages or proportions? Is the population standard deviation known or not? We find a specific test, appropriate test, parametric test, and then according to that test, get the standardized score for it's a T score or a Z score. And then that standardized score on the bell-shaped curve, we have a look, because we only do these tests that we assume normality, and then we look at the observed value and look at the probability of what we have observed, the standardized observed value. According to our test, is it a one-tail test or a two-tail test? Is it directional or non-directional? Which means that the alternative hypothesis, we say mu is less than, or mu is greater than a value, that's a one-tail test. If we say mu is not equal to a value, that's a two-tail test. So we find the p-value. In your readings, it has shown you the value that you can get for the two-tail test. So it is twice the probability of Z or T less than a value. Then you compare your p-value with your significance level. P-value is a probability. If the p-value was less than the significance level, which we said, we set it normally to 5%, then we have got enough evidence to reject the null hypothesis. Now, in this, again, we have said all the steps, which we said it's a systematic procedure. So we say that step 1 is restating null and alternative hypotheses. Step 2, we have determined the characteristic of comparison distribution. Are we talking about a z-test or a t-test? Because they have got different distributions. And then we determine the cutoff sample score, or we calculate the p-value, and then either compare the cutoff score with the observed standardized score we have got, and if the observed standard score was more extreme than the cutoff score, we reject the null hypothesis. We compare the p-value with the significance level, and if p-value was less than significance level, then we reject the null hypothesis. We should never conclude that the null hypothesis is true or it is false. We can only say whether we have got significant evidence against the null hypothesis or we have not got enough evidence to reject the null hypothesis. Now, p-value should always be expressed accompanying with the confidence interval, and if p-value was not very small or if the confidence interval was very large, it means that the standard error is large. It means that you should be very careful with the interpretation of your results. Now, significance tests, which form the very core of statistics, are used virtually in every journal article in science, medicine, psychology, economics, whatever, business. However, in the last few decades, due to the reports of increased alarming number of misinterpretation and overuse of these class of methods, in 2016, American Statistical Association issued its first alarming policy statement. And in 2019, there was an article published by Nature which emphasized on that. This statistics hypothesis testing was accepted by the Society of Science. It was proposed by Sir Ronald Fisher in 1920. You have to be very careful when you look at results for the hypothesis testing, and always look at the confidence interval as well. And you can read more about the problems with hypothesis testing in the chapter 10 of MATLAB as well. Now in here, I just wanted to emphasize on one-tailed test versus two-tailed test. A lot of you guys, when you finish this course, you should know what it means. In hypothesis testing, depending on the knowledge of the direction of the test, we can have a one-tailed test or two-tailed test. If, for example, we believe that the specific medication affects the blood pressure, but we do not know does it increase it or decrease it, then we use a two-tailed test, for example. If we know about the direction, we use a one-tailed test. So two-tailed test, I mean the not equal sign for the alternative hypothesis. One-tailed test, we put a less than or greater than. So for example, if we believe that, let's say, the blood pressure is less for a specific kind of people, so if the average blood pressure is 120, then alternative hypothesis, because we believe in this group of people blood pressure is lower, so we put a one-tailed test and we make the alternative hypothesis as less than. When a data scientist conducts hypothesis testing, as the population parameter is not known, he or she would not be sure whether he has made a wrong conclusion, even though he has utilized correct step-by-step hypothesis testing procedure. So that significance level alpha is the probability of rejecting the null hypothesis given that it is true. So that is a probability of type 1 error, we call it. And it is an indication of how rare your results are, assuming null hypothesis is true. Okay, so the researcher determines the significance level alpha before conducting the experiment, and alpha is normally 5%. Now, we have got another type of error in hypothesis testing. We call it type 2 error, and that is the probability of accepting alternative hypothesis when it is wrong. That is type 2 error, and then we have got the power of the test is power of the test is probability of not making type 2 error. So these are all the things that you should know really for an introductory statistics subject. Okay, so estimation is another inferential statistics we talked about. And we say that in reality, in many cases, we normally do not know the population parameter we said. So, for example, mean blood pressure of patients under a specific condition or mean number of disease trees in a large area. We don't know them. So we just estimate them. And the best point estimate for a population parameter is the sample statistics. For example, the best estimate for population mean, which is parameter and we call it mu, would be the sample mean, which is the statistics, and it is x bar. We normally produce a confidence interval with our estimate. That is a range of values to express how well the sample statistic estimates the underlying population parameter, or how much uncertainty there is with our statistic.